Hello and welcome back. In this video, we will review a question based on Newton's second law. So let's take a look at my example here. I have a 15 kilogram block being pulled down through a rope connected to a 5 kilogram block. So to start this off, I'm going to do a free body diagram. So let's first look at my first mass here. So I'm going to look at mass 1, free body diagram of mass 1. Okay? I look at this. Here's my mass. I have, first of all, my normal force and force of gravity, which balance out. Now, I have tension pulling this way. And I have force of friction pulling this way. My tension should be bigger than my force of friction. That's what's going to cause this brick to accelerate that way. All right? Now let's look at mass 2, my free body diagram of mass 2. So for this one, all I have is the weight of it pulling it down, so the force of gravity pulling it down, and I have the tension trying to keep it up. And we're going to assume that this is going down, so we're going to say my force of gravity is bigger than my tension. Okay? This tension here should equal to the tension here. Here the tension's in Y, here the tension's in the X. So now that we have that, now we're going to look at each situation separately. We're going to look at the free body diagram of mass 1 first and calculate what everything should be, or make an equation. So let's look at mass 1. Okay, we know my net force is equal to my tension minus the force of friction. Right? Because we have the tension is bigger than the force of friction. So my net force is equal to mass times acceleration. My tension is just going to be tension, and my force of friction we know is 30 newtons. All right. Now we know the mass is equal to 15 kilograms. So I have 15 times my acceleration is equal to my tension minus 30 newtons. Okay. Now let's look at free body diagram for mass 2. Okay, and let's see how this system works. Here, my net force is equal to my force of gravity subtract my tension, because it's going downward. So my force of gravity is greater than my tension. And we want to know how much more greater it is. So let's start solving this one here. So I have mass times acceleration is equal to mass times gravity minus my tension. My mass for this one here is 5 kilograms. So we have 5 times acceleration is equal to 5 times 9.81, subtract my tension. We end up getting now 5 times acceleration is equal to 49.05 multiplied by, subtract tension. Now, we look at this here, we have two different equations with two different variables. So we could combine these equations in a system of equations. So I'm going to solve for t here and use substitution. So if I just add 30 to both sides, I'm going to get tension is equal to 15 times acceleration plus 30. Okay, all I did was added 30 to both sides. Now I know that this tension is the same as that tension, so I could substitute this in for that tension. So let's write that out over here. We're combining these two formulas, so we're going to write it right in between them both underneath. So I'm going to have 5 times acceleration is equal to 49.05 subtract 15 multiplied by acceleration plus 30. I had put those in brackets because we have to use our distributive property to use that negative into both terms. So I'm going to have 5 times acceleration is equal to 49 0.05 minus 15 times acceleration, minus 30. Okay? Now we're going to solve this. So I'm going to add 15a to both sides. So I'm going to get 20a. We're going to combine these numbers, which is going to give me 19.05. Now I'm going to divide both sides by 20, so I get my acceleration is equal to 0.9525 meters per second squared. Now I look at this in my significant digits, 5.0, 2 digits, 2 digits, so my acceleration is actually going to be equal to 9.5 times 10 to the negative 1 meters per second squared. Now let's look at my next part here. We want to find, so we have A is done. Okay, here's my answer for A. Now we want to find B, which is my tension. So my tension for this one is, we already kind of solved for it there, tension is equal to 15 kilograms times my acceleration, which is 0.95 meters per second squared, and then we want to subtract my tension. We want to add 30 newtons, which is the force of friction. And that makes sense. My tension must overcome both the mass of this and the force of friction, and that's what gives me my acceleration. So I multiply these together, and then add, I'm going to end up getting 44.3 newtons. So in other words, we get 44 newtons in total. So that is B. My tension in the rope is 44 newtons. So that is how we solve one of these questions based on Newton's second